Okay, I want you to get your homework out from yesterday. Remember yesterday we did the PRZs, finding the rational and the real zeros. I will give you a hint on 36. There's a whole lot of PRZs. They're both fractions, and I'll actually tell you one of them is -4/3. And so then that leaves a little less to practice or to try to get on those. What other ones do I want you to look at? Maybe 51? No, let's not look at that one yet. 47, let's look at 47. I should have this planned out, right? If you look at 47, sometimes people get confused on those. On the ones before that, like 39 and 42, those are just like the ones we did in our notes where you're just checking. But 47 kind of gives you another reason to use upper and lower bound. So it says in the directions, use the upper and lower bound test to decide whether there could be real zeros for the function outside the window shown. If so, check for additional zeros. So on 47, look at that graph, which I'm not going to draw that graph perfectly, but if you look at it, it tells you that it goes from -5 to 5, and it kind of gives a lovely little graph, something like this. And so what they say is, what if we use the upper and lower bounds to figure out, are there any zeros bigger than 5? Like, does this graph, I guess I shouldn't put arrows on this because we don't know for sure. We're so used to this, putting arrows on it. We don't know for sure what happens. Like, does this graph turn and come back up at some point over here? Or does it just keep going down forever like this? Does this graph keep going up like this? Or does it turn and come back down somewhere outside, I guess it would be outside like this, the window? So instead of using upper and lower bounds to test for PRZs, a use for them is doing something like this. So they give you that equation, x to the 5th minus 4x to the 4th minus 129x cubed plus 396x squared minus 8x plus 3. So to check for, is there anything bigger than 5, we could do the upper bound test for 5, 1, -4, -129, 396, -8, and 3. And remember that if it's an upper bound, then that means these should all be positive numbers. So at some point, if we don't get a positive number, that means that 5 is not an upper bound. And I think if I do this and I get 5 here, I get -124. So because these are not all positive, I can just stop and I can say 5 is not an upper bound, which means there could be a 0 somewhere out here. And then it says the same thing for -5. But if it's a lower bound, remember that this should alternate. So it should go, if this is positive, then it should go positive, negative, positive, negative. So this would be -9. This would be 45. So what would that be? 12, 80, -84. So again, because it doesn't alternate, I can say that -5 is not a lower bound, which means that there are other zeros outside of this. And so if you had a graphing calculator, because it says, if so, check for additional zeros. And that's where we could use the graphing calculator. And I guess I could pull that up really quick to show you that I'm not making that up. And we could change the window and we could try to get answers there. Obviously, I'm not letting you have a graphing calculator on the test, so I wouldn't make you actually find them, but that would be a good reason of why we would use these upper and lower bound rules. So on the y equals over here, if I type this in, x to the 5th minus 4x to the 4th minus 129 x cubed plus 396 x squared minus 8x plus 3. And I really need to change my window. So I'm going to go to my window right here. And it had negative 5 to 5. So I'm going to go negative 15 to 15. And I don't know. We could make those. We could just keep it going by ones, I guess. And it was going from negative 1,000 to 1,000. So I'm going to keep it for the y values. Oops, look, I messed up my scale there. This should be clear 1. I'm going to make my y values the same as theirs so that you can see that it's the same graph. Oh, not 10,000. And let's make this go by like hundreds or something so there's not a million steps. I think, oh, here it comes. I guess I could go all the way up to like 3,000 or something because we're not even seeing what happens up there. All right, I'm going to change my window. I'm going to go negative 5,000 to 5,000. Let's see if this is better. Oh my gosh, how high does that go? Okay, I'm done. I'm done trying at this point because I don't really need to see the whole thing. What I need to see is the other zeros. And so we can see that there's a 0 out here. And if we want to kind of estimate that, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 at about negative 11. And out here at 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. There's another one. And then the book says that approximately negative 11.002 and 12.003. But that's another use for the upper and lower bound, so I just wanted to show you that. Also, maybe let's look at one of those last ones where it says find all the real zeros. Both 51 and 54 are kind of nice. I want to do 54 because it's a fourth power, and that's the one we didn't get to yesterday. I guess I should shut this. '54 says f of x equals x to the 4th minus x cubed minus 7x squared plus 5x plus 10. Really nice that there's a coefficient of 1 in the front, so we're not going to have to check any fractions. But it is a fourth power, so I was kind of hinting at this yesterday. But for my PRZs, I would get plus or minus 1, plus or minus 2, plus or minus 5, plus or minus 10. And if I check 1, I get 1 minus 1 minus 7 plus 5 plus 10. That's not going to work. If I check negative 1, I get 1 plus 1 minus 7 minus 5 plus 10. 12, 10, 11, 12. I think that works. Is that true? Yeah. 2 and 10 is 12. Negative 7 and negative 5 is negative 12. Which means that does equal 0. So if we divide that out, so x equals negative 1 works. So if I divide that out using synthetic division, the difference between this problem and the ones we did yesterday is all the ones we did yesterday were third degree. So when we divided it out, it was a quadratic. But on this one we divided out, it was a fourth degree to begin with. So now I'm going to get x to the third minus 2x squared minus 5x plus 10, and I'm going to have to solve that. You have two options here, okay? One option is keep guessing, all right? We still have a constant of 10 and a leading coefficient of 1, which means we can go back through and check the same PRZs that we had before. Another option that sometimes works is some people recognize that you can do factor by grouping on this, where you can group together the first two and the last two, and you can get your answers that way. And that works on this problem. Not all problems are factor by grouping, but I just want to let you know if you recognize that, you can do it. I'm going to go ahead and keep guessing. And so if I checked 1 and -1, I'm going to go now and check 2, and I get 8 minus 8 minus 10 plus 10. Which I think that also equals 0. So now if I factor or divide out 2 with what's left, 1, -2, -5, and 10, now I get my quadratic, which was going to be x squared plus 0x minus 5. So when I solve that, I'm going to add 5 over, take the square root, and I get x equals plus or minus the square root of 5. I also found that x equals 2 and x equals -1 works. And I think they say identify each zero as irrational or rational. So these two zeros are irrational, but these two zeros are rational. Usually people have a question on 57. I told you you just have to set 57 up. It's kind of more of a graphing calculator problem to solve it. But it says the Sunset Small Appliance Company determines that the supply function for their Evercurl hairdryer is um, 6 plus 0.001 p cubed, and that the demand function is 80 minus 0.02 p squared, where p is the price. If any of you are in econ, you know you talk about supply and demand. It says to determine the price for which supply equals demand. They're telling you the equation right there. Determine when supply equals demand. So you're just going to set these two equations equal to each other. And then it says, and the number of hair dryers corresponding. Well, we didn't solve this because we would need to set this equal to 0 and do it on a graphing calculator where you could look for the zeros. But just so you know, the answer was $36.27 and 53.7 hair dryers, which I think we'd have to round to 54 hair dryers because I don't think we could sell 0.7. But I just wanted to give you that to kind of show you where you can see polynomial functions in other disciplines like econ. Hopefully you did the rest of this homework and you're kind of caught up on this because I have a homework quiz for you today over 2.3 and 2.4. I don't think there's anything from yesterday's homework, but maybe definitely 2.3 though and 2.4 day 1, and then there's one at the bottom that you just have to work out. I've left directions with the sub that I need you guys to alternate rows like we normally do to take this, and you can use your notes and your homework but not your book or your neighbor. And when you're done, you're just going to turn it in, and then you get a worksheet that's due tomorrow. Okay?